Hi, this is Karen Launchbaugh at the University of Idaho. Today I'd like to tell you about a project called Restore New Mexico. It forms the basis of the assignment that we're going to do on cover in REM 410. The Restore New Mexico project was a pretty aggressive and a collaborative project where the BLM in New Mexico partnered with a number of other organizations and agencies to try to return many of the grasslands and woodlands and shrublands and riparian areas back to a more productive and ecologically healthy state. So one of the parts of this project was to do a lot of pre-treatment and post-treatment monitoring. Today we're going to use some of those data to see how cover changed in response to shrub treatments out of the Carlsbad field office of the BLM. I had the pleasure of working with several field offices in New Mexico in 2009, and while I was in Carlsbad, those folks told me about this Restore New Mexico project. At that time, they had treated their millionth acre, and now they've treated almost 2 million, 1.8 million acres, in an effort to try to improve the ecological health of those sites. I've listed at the bottom of this slide the address for which you can learn more about Restore New Mexico and about their progress and their tactics. So you might want to visit that website if you want to know more about this project. I'm going to talk today mostly about the treatment of shrubs with herbicides on rangelands near Carlsbad. However, the Restore New Mexico project is much broader than that. They have several projects that are involved that involve using mechanical and chemical treatments to reduce invasive shrubs along streams. And on the right-hand side of this slide, you see a before and after picture of a stream. The shrubs that are of concern are mostly Russian olive and salt cedar. There's also some projects in the upper elevation that involve prescribed fire to restore forests and woodlands back to a more natural density of shrubs, particularly in the ponderosa pine and pinyon juniper woodlands. Herbicides on annual grasses is also one part of the Restore New Mexico project. Throughout much of central New Mexico, there is a problem with cheatgrass and other annual grasses, and using pre-emergent herbicides has accomplished a reduction in those annual grasses throughout many of the treated areas. Again, we're going to talk about treatment of shrubs with herbicides. The goal of the project in general is really to reduce the existing invasive and noxious plants and return to a more desirable vegetation community. And in this case, desirable is something that was more the historic dominant community. You can see from this figure at the bottom, historically, most 2/3 of New Mexico was a grassland, the yellow dominated area on the left figure. Over time, shrubs have invaded into this area. There's a number of reasons for that. But regardless of the reason, there's been a lot of invasion of shrubs, and now on the right-hand side you see that orange area that is now shrub-dominated. So the goal of many of the projects in Restore New Mexico were to reduce that shrub abundance, and the overall they were hoping that that would benefit the watershed and stabilize soils and ultimately increase forbs and grasses and favorable shrub production that would improve habitat for a variety of wildlife. And the project that I'm going to talk about today was out of the Carlsbad field office of BLM. The projects I worked on involved applying herbicides to reduce shrub cover, and the shrubs in this case were mostly mesquite and creosote bush to increase native forbs and grasses, trying to get the community back to that historic vegetation composition, which was more grass dominated. And you see some before and after, 2 years after and 3 years after treatment. Sampling design was pretty straightforward. They used 100-foot transects per site. They looked at sites in a variety of allotments, and oftentimes they had 2 sites in one allotment. They measured the pre-treatment vegetation composition, and then 2 or 3 years later they measured the post-treatment. The study that I was involved in were pre-treatments done in 2006, and then the spraying occurred in 2007. And then we looked at data in 2009, so 2 to 3 years post-treatment. We were mostly looking at perennial grasses, and we were using the line intercept method. So again, in each allotment, the BLM had pretty detailed maps, and they used GPS location to find the plots that had been established before treatment. then a compass bearing that laid out the transect. There was a T-post that was at the origin of each transect, and each transect was 100 feet long, as I mentioned. Photos were taken at each transect, and I will show you several of those photos as they relate to the data here in a few minutes. The main plants then that were along these transects included the dominant grasses were probably Scleropogon brevifolius, which is burrow grass, and Threon, which is an aristida. There were a variety of forbs, though nothing was really dominant. The most dominant forbs would probably be broom snakeweed and dogweed, which was Dysodia. So those were the kind of dominant, most often found on plots. The shrubs, again, that were the target of Restore New Mexico in this area were largely mesquite and creosote bush, but there were a variety of other shrubs, as you will see in the data and in the photos. So I want to tell you just a little bit more about the specific details. We did use a line intercept method, and it was canopy cover that we measured. So we always looked at how long shrubs or grasses or forbs were along this transect of 100 feet. There's one interesting thing about these transect lines, these tape measures that are made for line intercept. It's kind of a clever way to make it easy to calculate percent cover. The transects are 100 feet long, but instead of having feet divided into inches, feet are divided into tenths of feet. So as you record the data, anytime you have 1 foot, that equals 1% on the transect. Or if you tally up your data and you have 5.2 units, that means you have 5.2%, because you have 5 feet and 2/10 of a foot. So for example, if you had a plant that covered from 5.2 to 6.2 along the tape, that would be 1 foot and it would be 1% cover. So as you look at the data for this assignment, just keep that in mind. These numbers like 2.2 would be 2 feet and 2/10 of a foot, or that would be 2.2%. So it makes it easy to calculate cover, although it seems weird to take a foot and divide it into tenths. But that's the way it's done. In the recording of data, another convention that most agencies, land managers use is to record plants with a 4-letter code. This is a really old system where you use the first 2 letters of the genus and the last 2 letters would be of the species. So PAIN is for Parthenium incanum or Mariola plant. Creosote bush, Laria tridentata, would be LA for Laria and TR for tridentata. So it's a pretty common system of using those codes. If you want to learn the codes or check any of these codes, you can find them at www.plants.usda.gov. I have also included most of the codes that we will have in this study in a file that is along with the assignment called Plant List for Carlsbad Study. Okay, now so let's talk about the study. We're going to look at 10 plots, so that would just be a small sample of the number of plots that the folks in Carlsbad looked at. They have the before and after treatment pictures and data. And here's the folks that I had the pleasure of working with. There's Susan, Calvin, and Mike. It was a pretty windy day out in the plains in October, but we did have a good chance to look at 10 plots, and I will show you those data here. Each plot was uniquely identified by the allotment it was in and then the study site. So again, some allotments had more than one study site location. This is allotment 8111, study site 1. And you can see that there was mostly creosote bush, a stand on the left before treatment. The pre-treatment data were taken on the 2nd of October 2006. Post-treatment data were taken on the 1st of October 2009. So you will see in all of these slides, most all of them were taken pre-treatment and post-treatment in October. So whenever you're trying to do pre- and post-treatment, it's always good to take them at the same season. Here's same allotment, 8111, but this is study site 2, so a different site in the same allotment. Again, this site is dominated by creosote bush, little tar bush, and you can see that pre-treatment data were taken on the 3rd of October 2006. Post-treatment data were the 1st of October 2009. Allotment 8144 on study site 1, that location, again, mostly creosote bush. The first data before treatment were taken on the 3rd of October 2006. The post-treatment, after treatment data were taken the 1st of October 2009. Here's allotment 8144, study site 2. Pre-treatment data were taken on 04 of October 2006. A little more of a diverse site. There's creosote bush, but there's also mariola and acacia gregii, which is catclaw acacia, and there's also tar bush. So before was on the 4th of October 2006. After was the 1st of October 2009. 8104 is a plant dominated again by creosote with some acacia gregii or cat's claw acacia. Pre-treatment data taken on the 4th of October 2006. Post-treatment data taken 24th of October 2008. Here's allotment 8104, study site 3. Site dominated largely by catclaw acacia. Pre-treatment data taken on the 5th of October 2006. Post-treatment data the 24th of October 2008. Allotment 8106. Treatment site 2, study site 2. Mostly creosote bush. Pre-treatment data taken the 5th of October 2006. Post-treatment data the 2nd of October 2008. Study site 8109. That's the allotment. Study site 1. Pre-treatment data taken the 3rd of October 2006. And you will see that this is a shrub-dominated site with very little understory. The post-treatment data was the 2nd of October 2008. Here's allotment 8109, study site 2. A site dominated by catclaw acacia. Before treatment data, the 4th of October 2006. Post-treatment data, 2nd of October 2008. Here's the last one, study site 8116, site 1. Data were taken in April in this case, so all the other data were taken in October except for this one, which was the 28th of April 2005, pre-treatment data. The post-treatment data was taken in early November, the 12th of November 2008. So there's just a little bit of difference in the timing on those two treatments. Okay, I'm going to load up this presentation, and I will also load just a file, a PDF of just these photos of the plots, so that in case as you're analyzing them you want to go back and look at what these sites looked at, you should be able to find that PDF. So enjoy the project. These are real data taken by real people. We cleaned them up a little so they'd be a little easier to read, but we're not cooking the books on this one. You should be able to see what the effect of the treatment was, pre and post, in this sample of 10 transects.